Salam sejahtera. My name is Nalini Arumugam from Universiti Sultan Zainal Abidin, Terengganu, Malaysia. Today I am going to share with you my research output on the title Unveiling the Determinant of Big Data Application Among Small Farmers. The United Nations posit the world population would rise to 9.7 billion by 2050. Therefore, agri-food need to dramatically and sustainably increase by more than 70%. Furthermore, main of the agricultural land is being taken away by rapid urbanization and climate change. The data that given is the proof for the rapid urbanization and the proof for the climate change. As we all know about deforestation, we are losing a lot of trees due to deforestation. 30 million acres lost every year, that is a given data. Due to deforestation, there is a loss of biodiversity and loss of natural resources that create global warming and as well as food insecurity. This is a big issue when we talk on agriculture activity. Farmland are being taken away again by rapid urbanization and climate change. Looking at the problem of, I believe all the problem got solution. The advancement of information, communication, technology and Internet of Things can be used in agriculture activity and to improve the agriculture practices as well as increase the yield of agriculture. So we are proposing precision agriculture through the use of big data devices for agriculture. So what is big data devices? Mobile phone, soil sensor, social media, drone, satellite and others considered as big data devices that can be utilized in our daily agriculture activities. Through that we believe that agriculture activity can be improvised. Since we are looking at small farmers in Malaysia, and we should know the social demographic of our small farmer in Malaysia. 80% of them actually producing agri-food in Malaysia. However, small farmers are lacking behind in embracing big data devices, even though they are the majority farmers in Malaysia. The critical pathway to increase the quantity and quality of food through big data devices is a question mark due to the knowledge, the lacking knowledge among the farmers. Also, apart from the provision of nutrition and food security to the country, small farmers also create and preserve jobs, especially in rural area, stop rural-urban migration and preserve the biodiversity. As we know, the population will reach 9.7 billion by 2050. So our concern is how can agri-food be intensively increased despite the rapid population growth versus depletion of agricultural resources. How are we going to feed the world? The solution, as I mentioned earlier, through the ICT and IoT. Therefore, for us to unveiling the determinant of big data devices among small farmers, we came up with 3 objectives. The first objective is to access information on existing technology that potentially can enhance big data application among small farmers. 2, identify the determinant of big data application adoption among small farmers. The third objective will be to ascertain the barriers of big data application among the small farmers. The adoption of big data application among small farmers in Malaysia is expected to enhance definitely on food production and security, modernization of agriculture sectors, youth empowerment, and definitely will develop the rural, social and economy. To answer the three objectives, of course, we have our method that we carried out. So the research design was mainly focusing on non-experimental survey, and it's in nature explanatory by purpose and cross-sectional in respect of time for the collection of data. As we know, the population of small farmer in Malaysia is 467,184 farmers. From this population size, we able to collect data from 349 small farmers from the category of livestock, vegetables, fruit, fishery, dairy, paddy. And we use structure equation modeling (SEM) as a data analysis using SPSS version 26. Let us dwell on a sampling method. The respondents were clustered based on Malaysian states, and the state with the highest numbers of small farmers were selected to represent the entire population. So, the small farmer from Johor, Kedah, Kelantan, Pahang, Perak, Selangor, Terengganu and Sabah were chosen for this survey. Stratified sampling technique was used to allow for the categorization of the respondent based on major agri-food commodity in Malaysia, such as paddy, vegetable, fruit, dairy, livestock and fisheries. And we use symbol random sampling. The respondents were randomly selected in each agri-food subsector. This process eliminates any form of bias, as every small farmer was given an equal chance to be selected. A face-to-face survey carried out using questionnaire as a tool for us to collect data on application of big data among the small farmer. Total variables, independent variable which used in this study was 6. They are innovativeness, proactiveness, risk taken, perceived usefulness, perceived ease of the use, and intention to adopt BDDA. So total 65 items or 65 statement as a tools for us, used tools to collect the data. All the items in questionnaire definitely was pre-test, or we call it as a pilot study was carried out. Pre-test was conducted to pinpoint any issue with the instrument, such as redundant ideas or awkward question formulation. Senior staff of Malaysian Ministry of Agriculture and practicing farmer who have years of experience checked the validity and reliability of the questionnaire. What you are seeing is the descriptive analysis values that represent by mean and standard deviation. For the pre-test, we able to collect 102 farmers, and all the questionnaire was analyzed and modified accordingly, and all the data we will see the next slide. We will look into the alpha value and how many items from each construct been removed will be discussed in the next slide. Exploratory factor analysis, in short EFA, was conducted to develop a reliable tool for measuring the construct. Questionnaire items were developed on a scale of interval 1 strongly disagree to 10 strongly agree. IPM SPSS statistic version 25.0 was used to perform EFA on the item using the extraction method of the principal component with varimax rotation. Also, the specificity test and sample adequacy access by KMO has been calculated and presented are the result. So each independent variable, 6 of them, the KMO value is more than 0.5, means that all the item, certain item was removed, but majority of the item can be used for the questionnaire and to conduct the further research. Test of compact alpha was calculated to assess the reliability of item retained. All construct has reached confa alpha above 0.7. The development of scale and validation has demonstrated accuracy and reliability of this instrument. From the independent variable or the construct, 6 variable. Total item earlier we used is 65 item. After running the test, confa alpha test, 51 item. From innovativeness we took 8 item, proactiveness we took 8 item, risk taking we took 7 item, perceived usefulness 10 item, perceived ease of use 11 item, intention is 7. So all the items that will be used for the further research will be 51 item and from the 65 item earlier. So this is the respondent profile. 349 small farmers were interviewed. Face-to-face interview section was carried out. As you all know, the agriculture industry is dominant by male, and most of them have secondary school education. So all are considered literate, able to use big data devices. Majority of them in the age of, not majority, mainly 31 to 40. In the age of 31 to 40 possess 28%, and followed by 41 to 50 years old, and most of them married, 86% of them married, and majority of the small farmer are Malay, that is 69%. Most of the farmers are doing agriculture activities or involved in this farming activities as a full-time farmer, and most of them own the land, and majority of them in the they have like 5 to 10 years experience in farming, and farm size, most of them own the farm between 1 to 5 acres. Okay, according to data that collected, 40% of the farmers owning farm size between 1 to 5 acres, and majority of them use their personal capital or model to operate their farming activity. Okay, this slide will prove us that among all the big data devices that listed in the questionnaire, majority of the farmers use smartphone as a big data tool to communicate, to do their transaction. Okay, so your majority of them using smartphone as a big data device. Okay, if we look at the farmer income level, 64% of the farmers getting income or monthly they earning around RM1,000 to 4,999 ringgit. Okay, total cost of farming, majority of them said or answered they are spending per month almost 500 ringgit to 2,500 ringgit. Okay, number of workers that involved in farming normally is less than 4, and the family that they need to take care of is less than 4 people in their family. Okay, this slide we will discuss on the determinants of respondent use of big data devices. Okay, when we pose the question on are you willing to spend money on agriculture technology devices, 208 farmers answered that they're willing to spend money, but make sure the spending money will give them return in terms of increasing the yield. And when we pose a question on do you record your agriculture activity, 173 said yes, but 130 said no. That is quite worrying us because for them they should know the importance of keeping all the information of their daily operation activity in farm. It's very important. Okay, when we ask about do you record your financial transaction, again 202 said yes, and still 101 farmers said no. Okay, once again financial transaction information is crucial as well. They have to know how much they are spending on the farming activities. Okay. And when we ask them, do you use smartphone to get information related to agriculture, 253 farmers said yes. So means that NGOs or agriculture related agency are transforming the information through the smartphone. Okay, and when we ask, do they have a good internet accessibility or connection, majority of them, that is 226 farmers said yes, they do have a good internet connection. We are at the end of the slide. Okay, data driven agriculture is the way forward to achieve food sustainability and security to meet the needs of the exponentially growing population. The proliferation of smartphone and the internet made the application of BDDA realistic, and participation of youth in agriculture should be encouraged, and it is necessary. Knowledge and skill should be improvised to small farmer to ensure smooth adoption of BDDA among Malaysian small farmers. With that, I think I end of this slide and I conclude my presentation. With this, I end my presentation on unveiling the determinant of big data application among small farmers in Malaysia. I hope that my finding can lead for a future research, and I'm looking forward to collaborate and work with UMRY, and see you in next section. Thank you.